Hi guys,
Hi.
how are you?
Good.
Good. So my big question for you guys is this: we have a test on Monday. Do we want to have class on Monday? I think for test one, we voted not to have class on Monday. Yes or no? Because we have a test then. I think technically speaking, I'm not supposed to double dip on my time to have class and then to have a test because I'm taking time to do the test. It's a 24-hour availability window, and I'm going to take time away from your other classes to do it. But I was going to do the test. Should not have class. I agree. I think we should do no. And then also my question for you is, when do you want the test to become available? I can make it start when our class would start on Monday. So time window. I can do 10:30 on Monday to 10:30 on Tuesday. Okay, so then that way, in case you have like class conflicts, you don't have to like try to figure out budget your time, because you could actually technically take it during the class period and log in. The test will become available then. I think that ends up being very fair, and then we don't have to worry about double dipping. I've done noon because of time zone stuff, but it seems like time zones haven't been too much of a problem. So how's that sound? So the time window, sensitive noon on Monday to noon on Tuesday, it'll be 10:30 on Monday morning to 10:30 on Tuesday morning. Okay, does that sound good? All right, good. All right, so we have two things. So there's no class on Monday, and I'm gonna start the availability window for the exam at 10:30. Right, which means you could technically take your exam during the class period. So that's good. So that way you don't have to worry about double dipping on the time periods and stuff. Okay, good. I'll post an announcement to remind everybody of that. So some things that are due, a lot of things coming due on Monday. We have our second problem set. This is problem set number 2. We have the rest of the homeworks. If you didn't pass in the homeworks from earlier chapter, like chapter 2.1, 2.2, whatever, go ahead and pass them in, and then I'll take a look at them. Your classwork, like I said, the classwork due dates were kind of, suggested due dates, but I want them due by when the exam starts. So if you can do your classwork, and I know classwork's kind of, a bummer, like, oh, is it really hard? How are we supposed to do this stuff? We have videos where I'm actually working through the classwork that'll help you. And honestly, if you just give me something to work with on the classwork, then I can give you full credit for it. It's just to kind of see that you're, kind of doing it. It's like class participation. So if you have zeros on your classwork for chapter 2, go back over the videos and take a look at the classwork for that and how to do those, and then you can submit those, and then I'll give you credit for that. We're coming up rapidly in the end of the semester. We've got our test on Monday, okay, and then on Wednesday we start on chapter 3. We only have 3 sections in chapter 3, and then the following Monday, so not this Monday, but the Monday after our test, we only have 1 class that week. We just have class on that Monday, and then we go into Thanksgiving break. And then we come back from Thanksgiving break, we only have like a handful of classes left. So we're kind of wrapping it up fairly quickly. Don't forget, we have quizzes in chapter 3 we have to deal with. And then we also have a problem set for chapter 3, which all these things I'll post next week. And then your projects coming due. I got project descriptions from a bunch of you. They all look very interesting. If you have questions on how to implement it, come see me in office hours and we can talk about it. Or we can, chat over email, whichever works best for you. Some of you guys didn't give me project descriptions, and I hope maybe you were maybe working with a team member, although it looks like others are working independently. Make sure that you are working on it. Okay, the project description doesn't, that's just a 0 credit thing, but that's just to kind of make sure that you're thinking about it, because you don't want to come down. We only have we have less than a month left to the semester, so you don't want to like come down on the weekend right before the projects are due and go, oh no, I have a whole bunch of stuff. So this is to get you starting to think about it. Okie doke. All right, so enough nagging on my part. And like I said, I'll post an announcement for this. So no class on Monday. I'll start the exam window on our class time so you guys can start it during class if you want. And then now I am here for you. If you guys want to ask me about, to go over the quizzes that we've had, I can go over quizzes for, I guess we did quizzes, quiz 4, I posted solutions for, and then and grades for. We also have, I can talk about problem set stuff and homework. We also have, remember I posted up, there's additional practice problems. Somebody's asking me, can you go over homework 17 and 25? Sure thing. Let me get those out. So this is kind of like a time period for you guys to ask questions. So you can ask them in the chat or you can say them out loud. Let's see. So we have a question 17. Yeah, 17 is a funny one. Let me get out my notes on that one. Give me just a sec to get my pen here. Okay, so homework. Chapter 2, oops, 2, question 17. Let me get this straight here. Good. Okay, so question 17 is a funny one. Let me read it. So it says, are these valid or are they gonna work? No, this is, it's a projection onto you. And what we're doing when they write it like this, what they're saying is projection onto you, projection onto you, projection onto you, right? We're multiplying it. We're doing the projection 3 times. It isn't like, it's confusing because you think, does that mean it's in 3 dimensions? What's happening? What it means is we're doing the same projection 3 times, okay? And then this is basically, oops, it's just basically whatever the projection is. It's the same thing over and over and over again. So I'm taking that point, I'm projecting it, I'm projecting it, I'm projecting it, or I'm projecting the vector. It doesn't change, right? Because I'm just, multiplying it there. That's part A. Part B, so this is the reflection, reflection around you, and I'm going to do that 3 times. So what this means is I'm going to do the reflection times the reflection times the reflection. Okay, so what happens is that's so because it's 3, right? So let's think, just as an example, let's say I'm going to reflect across the x-axis, right? So I go, I'm going to reflect, and here's my reflection. Here's my x, here's my reflection. So here's 1. I'm going to do the second one. 2, right? And then 3. Oh, so I'm back. It didn't really change anything. So if I go, I'm reflecting it once, I reflect it twice, I reflect it 3 times. So if the number of times is odd, then it's the same thing as just doing it once, right? If I do it twice, even, right? So if I go reflection here, that's 1, and I go do it again, like reflection times reflection, I'm back where I started from, right? I'm back where we were. So that's, I'll just call it the identity. So this is no change, right? So it's a funny question because when I read it for the first time, I thought, does that mean it's like cubed? But or does it mean 3 dimensions? But it just means I'm doing it 3 times. Part C says, okay, so rotation. So this is, I'm going to do rotation by theta, and then I'm going to go do rotation by theta again, and then I'll do rotation by theta again. So let's think about it, right? If I had something, and I'm going to go, I'm going to rotate, I'm going to go by, say, theta degrees, right? I'm going to rotate this much, and then I'm going to do it again. I'm going to rotate, so this is rotation by theta. And here's another theta. So this is rotation by theta again. And then here's another theta. Rotation by theta, right? So I've gone 1, 2, 3 times. It's the same thing as going rotation by 3 times theta. So if this were 30 degrees, I go 30, 60, 90, right? So I would have gone 3 times my theta. So this is rotation, oops, 3 times theta. Okay, so whatever this is, it's that n right there, right? I'm multiplying at that time. Let's see, this one says, D says projection inverse. So the projection matrix is not invertible. right? If we were to find its determinant, we would find the determinant's equal to 0. That's kind of a big clue. Can I get an inverse, a matrix on there? So projection's not invertible, so this doesn't exist. Right here, this is not possible. And you can kind of think about it in terms of like, if I have something I'm projecting onto, it's a scalar multiple of my vector, right? When I do a projection of a vector onto another vector, it's a scalar multiple. Well, there are many ways to get that same scalar. So how do I know, where do I go back to? So like logically thinking, those are the kinds of questions you're asking, right? But mathematically, I can't, the determinant's going to be 0. All right. E says, reflection. I want to do the inverse of my reflection. So let's do a graph again. So here's my x. Let's pretend we're just, I do it across an axis because it's easy to visualize and it will extend. So I'm going to take this point and I'm going to reflect it. And taking the inverse of the reflection brings me back to where I was originally, right? So this takes me back to where I was. So the inverse of my reflection is during the reflection again, right? So if I reflect across the x-axis, if I reflect back across the x-axis, I'm going to get my inverse. F is rotation, my inverse rotation. So let's think about that. I need to go back, right? So if I go, I'm going to rotate by theta degrees. Here's my rotation by theta. Now, if I want to go back, I'll do it in a different color. If I want to go back to where I was, I have to rotate, right, by, so the nomenclature for angles is positive angles go this way, negative angles go this way. So I'm going to go negative theta. So that'll take me back to where I started from. That's my inverse, right? You can also think about this as rotation of, say, 360 minus theta degrees, or 2 pi minus theta in radians, right? So I'm going to go, so to get back where I started from, I'm going to go full circle, but I'm going to go from here. This would be 360 minus theta. So whatever's remaining will bring me full circle. That'll take me back to where I was. That's the same thing as going minus theta. Okay, so that's question 17. And they're funny questions, right? Because it's not quite clear like what's being asked, but kind of think it through. Like I say, I always like to draw pictures that help me visualize what I need to do. And you said 25, right? Let me take a look. Let me look for my solutions. 25. Find the area of the parallelogram. Okay. So homework number 25. Okay, so homework number 20, find the area of the parallelogram with vertices. 0, 0, 1, 0, minus 1, 2, 2, minus 2. So I always like to plot these out, as you know. 1, 2, 3, 1, 2, 3. Okay, so 0, 0. I'm going to go over 1, 0. I'm going to go minus 1, 2. I'm going to go 2. Oh, wait. 2 minus 2. Huh. Wait, did I draw that right? Minus 1, 2. 2 minus 2. I'm not seeing how this is going to come out as a parallel. Oh, unless it goes like there. This is what happens when I'm not a great artist, but there you go. So it's kind of, it's this parallelogram, but it's all tilted, right? Okay, so now, now I'm going to see that I've got this, these should be parallel, and these should be parallel, right? So maybe I can, this looks like, you know, I can make that, right? I can do this. If I call this vector 1, so vector 1 is given by minus 1, 2. And then I've got another one here. So I'm going to go 2 minus 2. So here's another one, right? Because I want them to have the same initial point. So this is vector 2. And then vector 2 is 2 minus 2. And this is just the same, right? This starts at the origin, so it's easy to do like a displacement vector minus 0, 0, minus 0, 0, right? So I come up with a displacement vector. I could have done it from here to here too, but then I would have had to do more math, right? And I always like to work with zeros. So I got V1 is this point minus 0, 0. V2 is this point minus, so terminal minus initial gives me my two displacement vectors. So if I write this in matrix form, I can take V1, I'm going to go minus 1, 2, and I'm going to go 2, minus 2. Okay, now we want the area of the parallelogram is equal to the absolute value of the determinant, right? And the determinant could be positive or negative. So if I take the absolute value, that my area always has to be positive. So remember, it's going to be the absolute value. I have to go minus 1 times minus 2 minus 2 times 2. And it's an absolute value because it's an area. So this is going to be 2 minus 4, right? And this is going to be absolute value of minus 2, which is equal to positive 2. So that's the, oops, can you guys see that? That's the area of our parallelogram. But I had to make displacement vectors out of it.
So do any two vectors work?
Well, they're going to be the same, right? So if I did this vector minus this vector, I should get the same thing, right? I mean, this point minus this point. And then, so if this was my initial here, so if my initial was 1, 0, so let's try it with initial equals 1, 0, and then my terminal equals, this is going to be minus 1, 2. So if I go minus 1, 2, minus 1, 0, so I'm going to get minus 2, 2. Look, so it's basically just the flip. And then if I do this one here, right? So it's going to be terminal, my initial is going to be 1, 0, and my terminal is going to be, wait, that was 2 minus 2 here. Did I do that right? Yeah, that's going to be 2 minus 2, right? So terminal minus initial, 2 minus 2 minus 1, 0. So 2 minus 1 is 1. That's going to be minus 2, right? So see how we're getting the same thing, only it's just we're going in the opposite direction, but they're scalar multiples of each other, right? So then if I line these up again, right, and I say, okay, so 1 minus 2 minus 2, 2, and I take that determinant, I'm going to get 2, right? Minus 4 is going to give me 2 as an area. So it's the same thing because it's a parallelogram. So these are parallel. So this is also V2 and this is also V1. Does that help you?
Yes, thank you.
Okay. I know it seems confusing and I'm just throwing around a lot of numbers, but basically I have this shape in space, right? And from any one point, I'm going to assign this point here as my initial point, right? So this is an initial point. Here's a vector, here's a vector, okay? If it's a parallelogram, then I know these two are parallel and these two are parallel. Okay, they're scalar multiples of each other. So that means I can make a vector out of here by doing terminal minus initial, which is what we did. This is minus 1, 2 minus 0, 0. V2 is terminal 2 minus 2 minus 0, 0. That gives us that other displacement vector. And then I put those into column form, V1, V2. And then you take the determinant, it's going to give me the area. Okay. Determinant's very nice. You don't have to do cross products, you know, you don't have to, right? Because we talked about doing the cross product of something to do to get the area of something, but the determinant's just going to get you right there. So I don't have to worry about the cross product. Problem set number 2, part C. Sure. Give me a sec. I just like to find it. All right, so this is P set number 2. So linear transformation, okay, yeah, all right, good. Okay, yeah, so we're given a bunch of things. So let's just go through. So I've got A1, 0, 0 equals 0, 2, 0. And then A1, 1, 0 equals 1, 1, 0. A0, 0, 2 equals 2, 1, minus 2, right? So we had to find, let's just do part A, B, and C. So find for part A of 0, 1, 0. So this is my unit basis vector. So in terms of trying to figure out what A is, this is my unit base, 1, 0, 0 is a unit basis vector. So this is my first column. So this is going to be 0, 2, 0. Okay. My second column is going to be found from my unit basis vector. This is J, this is I, right? My second column is going to be found by that. Now I can use these bits and pieces that I have here. So let's do this one here first. So B is find A of 0, 0, 1. This one's easier because look what we're given. If I transform 0, 0, 2, right, I get this. Now to get 0, 0, 1, I have to divide this by 2. It's going to equal A 0, 0, 2 divided by 2 gives me A 0, 0, 1, right? Because I divide it. Well, that means I take this, oops, sorry, 2, 1, minus 2. That's my answer. And I divide that by 2. So it becomes 2 divided by 2 is 1, 1 divided by 2, minus 2 divided by 2. So it becomes my third column, right? And now I have to figure, I can use those to figure out this one here, my Y. And so I can use that part to help me do that. So now, let's see, to get this bit, right, I'm going to take a look at if I've got 1, 1, 0. So if a 1, 1, 0 plus something is going to give me 0, 1, 0. How do I go from 1, 1, 0 to 0, 1, 0? Well, that means I need to subtract out this bit, right? So if I subtract 1, 0, 0, I'm going to get 0, 1, 0, right? So 1, 1, 0 minus 1, 0, 0 is going to give me 0, 1, 0, right? So I was given this, and I was given this. So I'm going to plug those in, right? So I'm going to go, that's equal to here. So I'm going to say, and this is going to be equal to that. So I'm going to go 1, 1, 0 minus. So my transformation is going to be 0, 2, 0. So I'm going to go 1 minus 0 is 1. 1 minus 2 and 0 minus 0. And that gives you my second column, which answers our part C. This is our second column. This is actually part C. Additional practice problems, part A. It could be typo, let's see. Practice problems 9. A, be the reflection on the axis, and C, be the composition. Let's see. All right, so so we say A be the reflection on the y-axis. Y-axis. So so let's write out reflection on the y-axis, right? So if I'm going to go y-axis, so if I have a point here, x, y, and I'm going to reflect on the y-axis, right? I'm going to get minus x comma y. So my how I go to do that reflection is my x becomes negative and my y stays the same. So this is my A matrix, right? And then let's see, we were given B equals 0, minus 1, 2, 1. And then C is composition of A followed by B. Wait, so what did they, let me read the exact question here. Okay, yeah. Okay, so let's keep working through. Find the matrix that represents C. C equals what? Okay, so C is the composition of A followed by B, which means, remember how we do these things, we do them in order this way. So of A followed by B. So the order I'm going to go is, so I've got something that I'm going to transform, right? I've got this thing to be transformed, to be transformed. To do this, the order of multiplication is I need to do A, and then I need to do B. Okay, so my matrix multiplication has to be set up like this. Remember, B times A is not the same thing as A times B, right? So you always have to think about how you're setting up. So if I do like, if this is like an X and a Y, right? I'm gonna go, this is what I wanna transform. I first multiply it by A, because it says that. We're gonna do A followed by B. So I'm gonna set up, my A is gonna be, and they gave us B, right? So now to get my, to get my C matrix, C is this. So this is, let's check our dimension, 2 by 2, 2 by 2. So the inner dimensions agree. My answer is going to be 2 by 2. So I'm going to go first row times first column. So 0 times -1 plus 0 times 2. First row, second column, 0 times 0 plus 2 times 1. And then second row, first column, -1 times -1, positive 1, plus 1 times 0. So 1. Second row, second column, -1 times 0 plus 1 times 1. So that's equal to C. Why C is B times A and not A times B? Yeah, okay, so to answer your question, it's like this. This is the order that we're talking about. Right, because you always, yeah, does that help? And that, it's a real nitpicky thing, because in matrix multiplication, A times B is not equal to B times A, right? And so, but when we do transformations with a matrix, we have to watch our order. We always line up all of the transformations that we're going to do. And this is the thing, we always put it like this. I'm going to apply it to X, Y, right? So, but then my order goes like this. Imagine it, we were told one, what did they say? We're going to do, first do A, two, sorry, then do B. So imagine my first step is I'm going to go A -1, 0, 0, 1 times X, Y, right? I'm going to get some value. This is going to be like X1, Y1. I'll call that, or let's XA, YA, right? Now my second step is to take B, which is going to be, what is B? 0, -1, 2, 1, and then multiply it by XA, YA to get XAB, YAB, right? So that's what we're doing here when we say first do this, then do that. And it's going to be important that we do it right, because imagine, so this is, A is a reflection on the Y axis. So if I've got a point, here's my XY, here's my Y axis, I'm going to reflect it first, and then I'm going to rotate it, say by 30 degrees. Imagine if I did it differently, like if I rotated it by 30 degrees and then I reflected it, it would be different, right? So I have to be very careful, like the order that I do things in. So you have to read the question. If it says, do this thing first and then do that, then you're going to do this thing first and then do that. Okay. Does that help?
Yes.
Problem set number 3. Sure thing. Okay, does everybody have this here? I'm gonna turn the page. All right, so this is P set. And then question 3. Okay, so P set question 3 says, T is a composition of counterclockwise rotation of 30 degrees. So counterclockwise, right? Clockwise is going this way, counterclockwise. So we're going to rotate by 30 first. Okay, followed by a reflection in the line 1, 1. So we're going to do the rotation first and then the reflection. Okay, so the line 1, 1. Okay, so now I have to think of a couple different things that I'm going to do. So 1, 1, x plus y. So we're looking at, and then we want to find t of 2, 1. Okay, so, right, I have to do this. I have to do the rotation first. Rotation by 30. So let's do this 2, 1. And then, whoops, sorry, reflection 1, 1. Right, so this is the order that we're doing stuff in. Okay, so all right, so now to find this, I have to find this reflection. So this rotation by 30 degrees. So let's just write out that first. So rotation by 30 is going to look like a rotation matrix, cosine of 30 minus sine of 30, sine of 30, cosine of 30, right? Make sure you're in degree mode when you do on your calculator. I'm going to just round, so I get 0.8. 66, 0.5, 0.5. Okay, so this is my rotation by 30 degrees, right? All right, now reflection in the line 1, 1. So reflection, remember, is 2 times the projection minus our identity matrix, right? This is, remember how we figured out, oh, I've got this line. So if I want the reflection, it's just, you know, the projection is halfway between the reflection and the point. So the reflection is 2 times the projection minus the identity. So I have to figure out this part here. So P11. So that is, that's this times its transpose divided by its dot product of itself, right? So this is U times U transpose divided by U dot U. So I'm going to go 1, 1, 1, 1. Okay, so this is 1 times 1 plus 1 times 1. So this is 2. So this becomes 1/2 times. So this is, let's see, 2 by 1, and this is 1 by 2. So my answer is going to, it'll work. And then my answer is going to be 2 by 2. So first row, first, whoops, sorry, first row, first column, first row, second column. Okay. So now I get to plug it all in, right? So this is 1/2 times all of this. So remember, I'm going to multiply by 2. So my reflection, sorry, 1 by 1 equals 2 times 1/2, 1, 1, 1, 1. Did I do that right? Yeah. Okay, oops, yep, 2 times 1, 1, minus 1, 0, 0, 1. Okay, so these cancel, right? And I'm going to be left with now 1 minus 1, 1 minus 0, 1 minus 0, 1 minus 1. Okay, yes, that's my reflection. Okay, so now, right? So now I'm going to go 2, 1 times my rotation minus 0.5, 0.866 times my projection. Make sure you get your order right. Remember, we always do it this way. I do the rotation first and then the reflection. Okay. I can combine these into one matrix or I can do them one at a time. It doesn't matter. I think it looks like I combined these into one. So I multiplied all these out. I got 0.5. That was here, and I'm just going to do this. But you could do them. You could do them one at a time. It doesn't matter, or you can matrix multiply to get one matrix. And then I'm going to. This is going to be 2 by 2, 2 by 1. So my answer is going to be in a 2 by 1 format. So 0.5 times 2 plus 0.866 times 1 is going to give me 1.866. 0.866 times 2 plus minus 0.5 times 1. That's going to give me 1.232. And then so basically our point 21 becomes, or vector 21, whatever it is, becomes 1.866, 1.232. You could have left it here, it's fine too. Okay. We can also go over the quizzes too, if you guys want. Any other questions, you guys? Classwork problems, quizzes, problem set questions. I also have office hours today. You're welcome to come too. I'll have office hours on Monday, but I ask that you not come to office hours if you've already started the exam. Okay. The homework, classwork, problem set are all due at midnight on Monday, but the exam you can start at 10:30 on Monday. If you guys don't have any other questions, we're free to end class a little bit early. I'll post this stuff here onto our webpage so that we can have it, so you guys can take a look at it later too to answer any questions.
Thank you. Have a great day.
Thanks, you guys. Anybody have, if you don't have any other questions, then you guys have a great weekend.
Thank you.
Take care.